Hello, my name is Prince Pal Singh. I am faculty of physics. Today we will study motion in two dimension or the motion in a plane. It has two headings. The first is the motion under constant acceleration and the second is the motion under variable acceleration. So we will study motion under constant acceleration, and especially it is motion under gravity. We also call it as the projectile motion. A particle is projected with an initial velocity u at an angle theta with the horizontal, and we resolve the velocity as the horizontal component is u cos theta and the vertical one is u sin theta. The particle is moving on this path. We have to write down the equation of the path. The equation of the path means we have to write down the relation between x and y coordinates at any instant when the particle is on its path. The relation between x and y is called as the equation of path or the equation of trajectory. For that reason, first of all, we have to use the equations of motion. The x component of the velocity is u cos theta and the y component of the initial velocity is u sin theta. The acceleration due to gravity is acting vertically down and x-axis is taken to be horizontal and y-axis vertical. Therefore, the acceleration is in the downward direction, so it is ay equal to minus g. There is no acceleration along x-axis because there is no force along x-axis. Therefore, the horizontal component of the acceleration is 0. Now if I will use the second equation along x-axis, so I will get x is equal to ux into t plus half axt square, where ax is 0, so the equation reduces to x equal to u cos theta times t. Similarly, we will write the equation of the particle along y-axis, the second equation of motion. So here y equal to uyt plus half ayt square is the second equation of motion when the particle is moving under constant acceleration. So uy is u sin theta and ay is minus g. We'll put it over here. So we will eliminate t from this equation, x equal to u cos theta into t. Let's say this is equation number 1. And then we will put that value of t in this equation. We will get the relation between y and x. So t is equal to x divided by u cos theta. We will put this value of t over here. So we will get y equal to u sin theta multiplied by x upon u cos theta minus half g and x upon u cos theta whole square, and this becomes y equal to x sin theta divided by cos theta, that is tan theta, minus g x square by 2u square cos square theta. So this is the desired equation. That is the equation which gives us the relation between x and y. X is the horizontal displacement and y is the vertical displacement. The relation between x and y is called as the path of the projectile or the equation of the path. This equation is linear in y and it is quadratic in x because it has got the power 2 in x and it is linear in y. Y has got one power only. And such equations which are quadratic in one variable and linear in the other one are called as parabolic equations. Hence we can say that the path of the projectile is parabolic. So the particle is moving on a parabolic path under the constant acceleration. Hello, my name is Principal Singh. I am Faculty of Physics. Today we will study how to derive the formula for the time of flight and how to derive the formula for the range for the projectile motion. Suppose the particle is projected with the velocity u at an angle theta with the horizontal. This is the x-axis, which is horizontal. This is the y-axis, which is vertical. The particle is thrown with the velocity u. The x component of the initial velocity is u cos theta, which is ux equal to u cos theta, and the y component is u sin theta, uy equal to u sin theta. The acceleration of the particle is always vertically down in this motion because the gravitational pull, the gravitational force of the earth on the particle is vertically down. So the acceleration is vertically down. So ay equal to minus g here. So ax is equal to 0. There is no horizontal force along x-axis. Now, how to derive the formula for the time of flight? For this, we will use an idea that the particle was initially thrown from origin, which the y was 0, and it falls over here, and again on the x-axis the y is 0. So the displacement of the particle along y-axis in the time equal to time of flight is 0. So I will write down the displacement equation, the second equation of motion along y-axis, y equal to uyt plus half ay t square. So I will put over here 0 for y, and it is u sin theta, and the time is equal to time of flight plus half ay is minus g into t square. From here you find out that the time of flight comes out to be, on solving we get 2u sin theta by g. So this is the formula for the time of flight, that is, in this much time the particle reaches from the point of projection to this point, like this. We can derive this formula by another method also. You see that at this point the velocity is horizontal, that is, the y component of the velocity at this point is 0. The time taken by the particle from this point of projection to this point is same as time taken from this point to this point. Let's say if the time taken from this point to this point is t, then the time taken from top point to the again reaching the x-axis is also t. So the time of flight becomes 2 times of t. So let's find out the time taken from the point of projection to reach the top. For this I will use the first equation of motion along y-axis, vy equal to uy plus ayt. So vy is 0 over here because the velocity is horizontal, and uy is u sin theta. So minus gt, so t equal to u sin theta by g. So this is the time from here to here. The total time is t equal to 2 times of t, which is equal to 2u sin theta by g. Now let's come to the range. How to derive the horizontal range? The horizontal range is the displacement of the particle along x-axis in the time which is equal to time of flight. So for this I will use the second equation of motion along x-axis, which is x equal to uxt plus half axt square. Now we know that ax is 0 over here and x is equal to r, so I will put u cos theta in place of t. I will put capital T, the time equal to time of flight. So you get u cos theta into 2u sin theta by g. So on solving this you get r equal to u square sin 2 theta by g. This is the formula for the horizontal range. If we throw the particle at an angle 90 minus theta in place of theta, let's say for example if we throw the particle at an angle of 60 degree in place of 30 degree, so what we get is if theta is replaced by 90 minus theta. So the range formula will become u square sine 2 times of 90 minus theta by g, and it is equal to sine 180 degree minus 2 theta by g. And this is equal to sine 2 theta again. It simply means that if you throw the particle at an angle theta or 90 minus theta, for these two angle of projection, the particle falls at the same distance. So these two angle of projections are complementary angles because their sum is equal to 90 degree. So if I draw the figure corresponding to theta, let's say this is the figure corresponding to angle theta. So if I throw the particle at 90 minus theta, again it will fall at the same distance. In this case, the angle of projection is 90 minus theta. So the range is same, but the time of flights will be different. In this case, the time of flight will be more, and in this case, the time of flight will be less. Now let's see at what angle the range is maximum. For maximum range, sine 2 theta is equal to 1. So theta is equal to 2 theta is equal to 90 degree and theta is equal to 45 degree. For this, the maximum range becomes R max equal to u square by g only. So this is the maximum range. So if we throw the particle at an angle of 45 degree with the horizontal, it falls at the maximum distance. Thank you.